All right, so next up, we're going to combine the two things this unit that we've looked at, which is exponential equations. And then on our last class, we just looked at the log function. Now, here's why we're going to use the log function is because there's several log rules or log laws, but there's a special one. And it says if you take the log of some power, which means you got an exponent going on, it's equal to take that exponent, put it down in front, and then figure it out. All right, so what that means is, for example, number one here, I've got find the log of 3 to the power of 20. Now, 3 to the power of 20 means take 3 and multiply it by itself 20 times. And so if I did type that into my calculator, 3 to the power of 20, I'm getting, I'm just going to say the numbers here, 3, 4, 8, 6, 7, 8, 4, 4, 0, 1, which is obviously a very big number. Now, if I take the log of that big number, again, remember in our last class, talked about how the log function initially was used many, many years ago to take big numbers and make them smaller because we didn't have calculators. And so if I take the log of that massive number, I get 9.54. Whoops, 54. All right, now, over here in example 2, it says find the log or 20 times the log of 3. All right, well, and you'll notice that all that is if you take example 1, I'm taking that 20 and putting it down in front. And I'm going to explain why here shortly, why we need that. So that takes 20 and find the log, times it by the log of 3. Now the log of 3 is a small number, so the log is actually going to make it even smaller. And so when I type in log 3 in my calculator, I get 0.4771212. Now, guess what? If I multiply that number by 20, I get 9.54. They're the same thing. All right, now, like I said, the reason we're using this log rule is, well, because we're going to start solving exponential equations. So, for example, solve the following equations using the log function. All right, so we have 4 to the power of x equals 320. Now, this is something new for you guys because you've never had to solve for an exponent when you're solving equations. The x is always down to be a normal number. And we're going to make that happen again because here's what's going to happen is the first step here is take the log of both sides. So what that means is I'm going to take the log of 4 to the power of x, and I'm going to take the log of 320. Let's put that little x in there so before I forget. There we go. All right, now here's the reason we do that. Is when I take the log to the power of 4 to the x, I'm going to use my log rule to bring x down to be a normal number so that I have x times the log of 4. Log of 4, there we go. And I still have this log of 320. Well, actually I can figure that out. The log of 320, let's see, takes a big number, makes it smaller. Log 320, and I get 2.51. So now what's happened is because I use that log rule, the x is now a normal number, just like we're used to before. And in fact, I can find the log of 4. Again, it's going to be a small number because 4 is already a small number. And in fact, I take the log of 4, I get 0.6 equals 2.51. And now what we have is an equation that we're used to solving. I got x times 0.6, or if you want, I could write 0.6 times x. It's the same thing. We always generally put the number first. But I want to get x by itself because that's what I'm trying to do here. So the only way I can do it is to divide this 0.6 off. And what I do to one side, I'm going to do to the other. And so those 0.6's divide each other out, and my x value is equal to, let me see here, 2.51 divided by 0.6. The answer is 4.18. And there we go. So we solved this exponential equation. We figured out what the exponent was. All right, let's try a couple more of those. This time we have 7 to the power of x is equal to 1200. All right, so once again, I am going to take the log of both sides. So I get the log of 7 to the power of x. I'll put that x in after. And I'm going to take the log of 1,200. All right. And again, let's put that x in there so before I forget. There we go. All right, now the log rule says I can bring that x down in front and just multiply everything. Log 7. Now again, when you have the log of a number, you can actually figure out what that is. And so if I take the log of 1,200, I get 3.08. There we go. All right, like I said, just said, log of 7. I can figure out what that is. So I have x times the log of 7. That's going to be a small number. In fact, it is 0.85. Again, you got to be able to find that in your calculator. All right, now my last step, get x by itself. It's multiplying by 0.085. So I'm going to divide both sides by 0.85. And those 0.85s divide each other out. And so x is going to be whatever 3.08 divided by 0.85 is. And I get 3.62. So again, using this log rule just allows us to make that exponent a normal number so that we can solve for it. All right, I'm going to try one more of those. This time we got 3 to the power of x is equal to 1350. All right, so again, I'm going to the first step. I'm going to take the log of both sides. All right, so let's put that power to the power of x. There we go. And now again, I'm going to use that log rule. So I bring my exponent down in front, and it's going to be multiplying log 3. All right, the log of 1,350. Again, I type that into my calculator. I get 3.13. All right, and as I've said, I can find the log of 3. It's going to be a small number. In fact, I'm getting 0.2 decimal places, 48. All right, is equal to my 3.13. And then my last step, getting x by itself, which I can do now because, again, x is a nice normal number. And so I'm going to divide both sides by my 0.48. All right, so those 0.48s divide themselves out. And again, my x value, I'm going to take my 3.13 and I divide it by my 0.48. And I get 6.52. And there we go. So again, our log function helps us solve exponential equations because we can use that log rule. Where is it here? I go back up to the start. There it is. Our log rule here, one of the log rules, or several of them, but it's the one we're using to solve exponential equations. Like I said before, you've never had it in math before where you had to solve for an exponent. But the log function allows us to do that. All right, so